So today we will be studying the concept of conjugate and modulus of a complex number. There are some properties. Actually, you know the meaning of modulus of a complex number, but there are some properties related to that. So first is modulus of a complex number. Very simple. It is if z is equals to, let's say, x plus I times y. Okay, where x and y are real numbers. This is the standard form. Standard form will only be with x and y both are real numbers. So modulus of z will be equal to x square plus y square. It's under root, and under root obviously we take the positive sign. Okay. That is modulus of z is equal to whatever is the real part of z, its square, whatever is the imaginary part of z, its square. And mind you that imaginary part is not I times y. Imaginary part is just y. Imaginary part is actually a real number. Squares addition under root. On the Argan plane, the representation of z is something like this. This is my z, which is x plus iy. This is x, this is y, and this is my point P. So modulus of z is actually distance OP, distance of the point P from the origin. This is the concept of modulus. Now modulus, some properties are there which comes handy to us. First one is z1 is one complex number, and z1 multiplied by z2. Okay, z1 is another one complex. I'm telling you to find out the modulus of the product, complete product. Z1 into Z2 is some third complex number, and telling you to find out modulus of the product. So it is same as modulus of first, modulus of second, their product. Now the verification we can do. Verification, I leave it to you as a work. I think there is, it's just a clerical work.
Sir, one scroll down, sir.
Just 1 second. Okay, quickly.
Done, sir. Done, sir. Done, sir.
So if z1 is a plus I times b, z2 is c plus I times c, where obviously a, b, c, d are all real numbers, means I have written z1 and z2 in the standard form. Then you can check that, sir, LHS. LHS is something, means z1, z2. Z1, Z2. Z1, Z2. The real part is what? Real part is AC minus BD. And the imaginary part is what? So the imaginary part is 8 into D plus B into C. So what will be modulus of Z1, Z2? So modulus of Z1, Z2 will be AC minus BD whole square plus AD plus BC complete square. It's under root. What will be modulus Z1? modulus z1 is a square plus b square under root, and modulus of z2 is c square plus d square its under root. Now what you have to verify yourself. Now this I'm telling you, verify yourself. That if I want to do this product, means under root of a square plus b square under root of c square plus b square is equals to under root of this. So you just have to verify that LHS RHS, that is AC minus b square is equals to RHS complete square. So LHS complete square, I will remove the under root sign, and RHS complete square, I will remove the under root sign. So it will be a square plus b square and c square plus b square. Now you just have to check whether these two things are equal. The answer is yes, they do comes out to be equal. So you will say that yes, so this property is verified. Shall I leave the verification to you? Okay. Will you be able to do it? Afrin Pujita?
Yes, sir.
This is just multiplication and the application of algebraic expressions that we studied. Then the second property is with respect to division. This is Z1 into Z2. The second property that we have is so Z1 divided by Z2. Z1 divided by Z2, its complete modulus. It will again be equal to Z1 modulus divided by Z2 modulus. The verification will proceed again as same thing. Okay. Yes or no?
Yes, sir.
This will be even more tougher, the division problem, because here the real part will be even more complicated and the imaginary part will be even more complicated. Means more a square plus b square whole square, something like that. So just verify. This is the properties with respect to modulus. Just 1 second. Yes. Okay. Now, when I'm talking about x square plus y square under root x square plus y square, you can definitely see, sir, that x square plus y square is definitely greater than or equal to x square. Also, x square plus y square is definitely greater than or equal to y square. This we can say only because, sir, y square means this first greater than this inequality we can definitely say because y square is non-negative, it's a positive. Y is a real number, therefore y square is non-negative. If y would have been complex, then this inequality not guaranteed. Y is real, so definitely y square is greater than or equal to 0. It cannot be negative. So since we know this inequality, we can I say that x square plus y square under root. This is a positive sign, obviously, and x square its under root if I take. So magnitude wise, the numerical value wise x, this will be greater. Yes or no? Numerical value wise. Or x square under root. X square under root, instead of taking as x, I will take it as mod x. Okay. So modulus of x. So what conclusion I am writing, sir? X, the numerical value of x is less than this positive number. So can I write this? If I write this inequality, real part of z, if z is equals to x plus iy, my z is equal to x plus I times y. So if I write this inequality, so real part of z, that is my x, its magnitude cannot be greater than this. So if magnitude, if it's a positive, maximum it can be up to x square plus y square under root. It's obviously with this equality sign, less than or equal to. And if this real part of z, if it is negative, means if x is negative, it has to be, it cannot go beyond square plus y square under root with a negative sign. Do you agree with me? This property, is it clear?
Yes, sir.
Similarly, for this, the argument that we did for here, the same argument I can do for here also, mod y less than or equal to under root of x square plus y square. So the second thing that I can write, mod y is what? Imaginary part of z. Imaginary part of z is again x square plus y square under root maximum, and minimum x square plus y square under root with a negative sign. That is real part of z is between negative of mod z and positive of mod z. Imaginary part of z lies between negative of mod z and positive of mod z. Okay. Yes. Multiplication. The important properties are only about multiplication, division, and this I've already.
Done, sir.
Now the next is conjugate. So conjugate of a complex number, if let's say z is written in the standard form, a plus I times b standard form. So a and b both are definitely real numbers. So what will be conjugate of z? Conjugate
Z equals to Z bar, no, sir.
conjugate of z, it's symbolically written as z bar. Conjugate of z, symbol is z bar. And what is the, how to write a z bar? So take the real part as it is. Z, the real part I will take as it is, and the imaginary part which is there, means b, I will take the opposite number. Now which opposite number? Multiplicative opposite or additive opposite? The opposite with respect to addition, that is additive inverse. So I will just take the imaginary part to be the additive inverse. So instead of b, now my imaginary part will be minus b. Got it? Yes or no? This is just the
Yes, sir.
definition. You just have to take the additive inverse of the original number. So if properties are, this is the definition of conjugate. So if now I tell you, let's say properties of conjugate. So z1 plus z2 complete conjugate, if I tell you, calculate. So will you be able to calculate? Think, if z1 z2 modulus like we did, z1 z2 complete modulus is equals to z1 modulus, or before that the basic property, let's say z is some complex number, you can calculate its conjugate, we get some other complex number, and the other complex number, it's again the conjugate, so you will get z only. How? Just a verification is pending. So let z is equals to a plus I times b. So how we will calculate z bar? So we keep the real part as it is, and the imaginary part which is there means b. So we take the opposite number, the additive inverse. So what is the additive inverse of b? So additive inverse of b is negative b. So that is nothing but a plus I times. And now this number, this is my z bar, its conjugate. So whatever my number is, whatever my complex number is there, its real part I will keep as it is. And the imaginary part, what is the imaginary part? So imaginary part is negative b. So we have to take the additive inverse of negative b. And additive inverse of negative b, is it b? Do you agree with me?
Yes, sir.
In school we used to study -2. Minus of -2 is +2. जो minus sign है, the minus sign which is there, it's the symbol for additive inverse. Same thing we are using. So conjugate of the conjugate is z bar is equals to z only. That's the first. Second, if you take modulus of z, let z is equals to a plus ib, or modulus of negative z. Negative z can you calculate? Or modulus of z bar, or for that matter z bar modulus with a negative sign. Even I times z, its modulus. Even I times z bar, its modulus. It's all one and the same thing. So z is equals to a plus ib. Can you see, sir, mod z will be equal to a square plus b square under root. So minus z will be what? Minus z will be equal to negative a plus I times negative b. So magnitude of negative z, it will be what? So negative a whole square, which is same as a square. Negative b whole square, which is same as b square, addition under root. Can you see that the first equality is verified? Yes or no? These two things are
Yes, sir.
equal. Then what? Z bar. What is Z bar? Nothing difficult. So a minus ib. So magnitude of Z bar will be what? Magnitude of Z bar will be a square plus minus b complete square. Minus b complete square whole thing under root. It's just again the same thing. We got a square plus b square under root. So again the second equality is also verified. My first equality were verified. Complex number and the negative of that complex number, their magnitude is same. So z bar is also some complex only, na? So negative of z bar is the negative of that complex number. So they are, we need not prove this equality again. It's proved earlier only in the first one. Okay. And now I times z. I times z is what? Can you tell me what will be I times z? Z is equals to a plus ib. Quickly, what will be I times z? Orally it should be done. You should be able to do it orally. Z is equals to a plus ib. Then what will be I times z? Pujita, Afrin. Okay, simple now. Why are you not answering? I times z will be what? Sir, I multiplied by this thing. Use the distributive law. I multiplied by a, and this I multiplied by I into b. So I into b. So I square is -1 and -1 into b. So negative b plus I times. Got it? Z equal to A plus IB, so IZ will be negative B plus I.
Yes, sir.
So what will be modulus of
Yes, sir.
I times Z? So modulus of I times Z will be real part square, that is negative B complete square, plus imaginary part. Imaginary part is A, its square, under root. So ultimately we are getting the same result. Okay. And I times Z bar also I think you can verify. What will be I times Z bar? What will be I times Z bar? On it should be done orally. We have done such complicated multiplication, so this is an easy one. What is Z bar?
A minus IB.
So what will be I times this? This is my A minus IB. Look on the screen. This is my A minus IB. I have to do I times A minus IB. So I times A minus IB will be what? I into A. That will be the imaginary part. And this I into A we have done, and this I into negative I times. So minus I square. Minus of I square means what? Plus 1, and that B is remaining. B plus IA. What will it become? B plus IA? Tell me.
No, sir.
Yes, no. What
No,
was?
sir.
This is my Z bar. Okay. This is my Z bar. I have to multiply I with Z bar. Correct?
Yes, sir.
I into A. Subtraction I into I, that is I square B. So I into A as it is. What is this I square? Negative 1. Minus of negative 1B. So won't it be
Yes,
plus
minus
B?
plus. Yes, sir. Yes, sir.
Happening. Simple. It was a simple multiplication. The modulus of I times Z bar will be equal to real part square plus imaginary part square, etc. So I think you can all see that these all things are equal.
Yes, sir.
Moving ahead.
Sir, could you please scroll down, sir? I have to copy it.
Done.
Done, sir.
Z multiplied by Z bar is always equals to magnitude of Z, its square. That is, Z into Z bar is always equals to real part of Z square addition imaginary part of z its square. So we have done a lot many times. The examples that I gave you of multiplication. Many questions we have solved of this type, like yeah, this question number 4. 5 plus 2 times I, 5 minus 2 times I. Do you realize that these two are conjugates of each other? 5 plus 2i and 5 minus 2i. The two brackets,
Yes,
two
sir.
complexes, they are conjugates. And we have multiplied this. We have done the multiplication. So 5 square subtraction 2i whole square. Afrin was asking this doubt yesterday. So it became 2 square and I square became a plus, minus of I square plus. So what did we ultimately do? So 5 square, 2 square addition. 7 plus 3 is 7 minus 3 is 7 square and 3 square addition. Yes or no? 8
Yes,
plus
sir.
8 minus 59, 8 square, 15 square addition. So this, what multiplication we were doing, it was just an application of the property. Which property? Z into Z bar equal to real part square and imaginary part square. And this is nothing but the modulus square. Okay, correct? Understood, Pujita?
Yes, sir.
Just if we take Z is equals to A plus IB, then Z bar will automatically be A minus IB and Z into Z bar. Z into Z bar will be equal to just the multiplication as we do usual, which is A square. A square is real part whole square. B square is what imaginary part whole square. So, okay. Fourth property is real part of any complex number Z is equals to, you take Z, you take its conjugate, their addition upon imaginary part of any complex number Z is equals to take Z, subtract its conjugate from it and divide it by 2i. So what's the explanation for this sum? Just how we used to solve linear equations. So Z is equals to A plus I times B. Z bar is equals to A minus I times B. Now what your target is? So can I find A? My target is what? Can I find real part of Z? That is A. In terms of Z only, in terms of Z and Z bar only. Yes, you will know the significance of this property. You will understand with respect to questions only when you solve them. Means right now you may be having doubts. Clear. It is visible clearly that A, the real part of Z equal to A. Why are we not writing it simply as A? Sometimes in the question we may need to write the real part in terms of the original complex number, in terms of the original Z and Z bar only. So there how we used to solve, these two unknowns are there, A and B, and how you used to solve the linear equations. So elimination method, substitution method, cross multiplication method, and so on. So just that only I did. We used to do. If I means think of it as equation 1, think of this as equation 2, and I want to find the value of A. So Z plus Z bar. If I just do the addition, it will become 2A. Just divided by 2, I get A, which is real part of Z. Correct? This A, which is my real part of Z. And in the original set of simultaneous equations, only if I do the subtraction, Z minus Z bar will be equal to A will get cancelled out. IB minus of minus IB will become 2I times B. So what will be B? B will be equal to Z minus Z bar upon 2I. This is equals to B, and this was my imaginary part of Z. Okay.
Yes,
Priya?
sir. Sir, we have to copy it, sir. Sir, I'm a bit down. Yeah. 1 minute, sir. 1 minute. 1 minute.
Done?
Yes, sir.
Here, these are the important properties. Z1 plus Z2 complete conjugate, same as so Z1 conjugate, Z2 conjugate separately, add them. Just a matter of verification. Z1 is equals to A plus I times B. Copy simultaneously, okay? While I'm writing, these verifications you can do yourself also. These are very easy sums now. Z1 plus Z2 will be what? So Z1 plus Z2. We add the real parts together. A plus C. I times. We add the imaginary parts together. B plus B. So what will be LHS by Z1 plus Z2? Complete conjugate. What will be? So if real part we keep as it is intact. No disturbance. And the imaginary part, complete negativity, complete opposite. So B plus D with a negative sign. This is my LHS, yes or no? So what is my RHS? Z bar, Z1 bar and Z2 bar. Z1 bar is actually A minus IB. What will be my Z2 bar? If Z2 is equals to C plus ID, Z2 bar will be C minus ID. Z1 bar plus Z2 bar will be what? A plus C plus I times negative B, negative D, yes or no, which is same as Z1 bar plus Z2 bar is equals to A plus C minus I times in bracket B plus D. Can I say that these two things are one and the same thing? Got it?
Yes, sir.
If with respect to that only, if I tell you Z1 minus Z2 complete bar, Z1 and Z2 two complex numbers are given. I tell you to find different, the conjugate of the difference. Conjugate of the difference will be what? Conjugate of the complete difference is first number conjugate, second number conjugate, their difference. So you can separate the bar sign. Same method verification, just here instead of addition, we're doing subtraction. Okay, verify yourself. I leave this to you. I think there is no, yes, this is very easy. You will be able to do it. Okay. Ujita Afrin, will you be able to do?
Yes,
Yes,
sir.
sir.
We'll try.
Same method, just what will be get replaced in the above thing, z1 minus z2. Here, instead of a plus z1 minus you do. So a plus is subtraction b plus, sorry, plus I times, it will be instead a, when you take z1 minus z2, here it will be a minus c plus I times b minus b, correct? So z1 minus z2 bar is a minus c plus I times b minus d only, plus I times b minus d. And z1 bar is a minus ib, z2 bar is c minus id, z1 bar minus z2 bar, so a minus c minus I times, and you do the further things, you will be doing. Those corrections that I'm doing in the purple, they are not visible properly. So you only do it yourself, it will be visible. Addition and subtraction, you can split the bar sign. Now with respect to multiplication, z1 multiplied by z2, its complete bar. For modulus, we change the sign, means we split it, modulus z1, modulus z2. For bar also, means for conjugate also, you can split it. z1, z2, its complete conjugate is equals to z1 conjugate multiplied by z2 conjugate. Verification. So what is z1? z1 is equals to a plus I times b. What is my z2? C plus I times b. What will be my z1, z2? AC negative BD. This is my real part, and the imaginary part will be AD plus BC. So LHS will be what? So LHS is equals to Z1, Z2. It's complete conjugate. So can I say my LHS will be the real part as it is? Do not disturb. And the imaginary part, you take the additive inverse, so negative I times AD plus BC, correct?
Yes, sir.
For
Yes.
RHS, Z1 bar will be A minus IB. Z2 bar will be C minus ID, correct? And can you do these two multiplications if you have two simple complex numbers? These are some two simple complex numbers. Call it, let's say, Y and Z. Z is already different. P and Q. P and Q, two complex numbers are there. You have to simply multiply that. So how you multiply? Just the cross multiplication, distribute term by term that you used to do. AC, this minus minus will become plus only. So plus I square BD. So AC into positive I square BD. The positive I square BD is what? Actually negative BD. This is the real term, real part, and the imaginary part is minus I times AD minus I times CD. So minus I will take as common, and what will remain? AD plus BC. Is this step clear? For the cross multiplication.
Yes, sir.
Minus I AD minus I BC, and Z1 bar Z2 bar AC minus BD minus I times AD plus BC. We got the same thing. The last thing is for division. Z1 upon Z2. You divide them. After division, take the conjugate. Same as conjugate of the numerator divided by conjugate of the other complex number. This part I leave it to you. Okay. Is the properties clear so that I can move on to the questions of these application of these properties? Copy down quickly.
Done, sir.
Do that modulus of plus 4 times I upon 5 plus 12 times I is equal to 5 upon 30. Using mod z is equals to real part of z square plus imaginary part of z square. In this question, it is explicitly said that you know only this definition. Modulus of z is equals to what definition do you know? Real part square, imaginary part square under it.
Done, sir.
It cannot be done so quickly. If you are applying the properties of modulus of numerator upon modulus of denominator, that property you don't know. What I have told, prove that this equal to 5 by 13 using question, read it till end.
Yes, sir. In this manner only I did.
So what is real part of this z?
I got 5 by 13. I proved it, sir. Real part is 9 by 20.
9 by 20.
5, sir. 25. So we have to separate it.
Afrin, are you getting? Afrin Dhananjay also joined.
Yes, sir.
What will be real part?
What, sir?
What will be the real part of this complex number? See, z is equals to 3 plus 4 times I upon 5 plus 12 times I. This is your z. Do you right now know, means as it is given in the straight form, as it is given in the straight form, do you know the real part of this z? As of now it is unknown. Imaginary part of z, as of now it is unknown because z is not given to us in the standard form. Real part, real number plus I times real numbers. Z is not given in the standard form. So how to do this then? The only definition we know is real. He has explicitly mentioned, particularly he has mentioned using only this definition, real square plus imaginary square under it. So what is our target? Our target is to find, so first find the real part, then find imaginary part, take squares, add under it. So how to do that? So z is equals to, and you know we have done lot many questions of this form, 3 plus 4i upon 5 plus 12i, division by something. This is the wrong method, but we do it for our convenience. 5 minus 12i upon 5 minus 12i. The reason also I have told you why it is wrong. So now this is just 3 plus 4i into 5 minus 12i upon the denominator it will be 5 square plus 12 square, correct? So now in the numerator
Yes, sir.
it will be 5 3s are 15, 12 4s are 48 with a negative sign, but I square is there, so I will have to change that signature, correct? And then
Yes, sir.
5 4s are 20i and negative 36i. 20 minus 36 is minus 16 times I. And in the denominator, there is 13 square. 48 plus 15 is how much? 63. Minus 16i upon 13 square. This is my Z. Am I doing it correct? Okay. So Z is equals to 63 upon 13 square minus I times 16 upon 13 square. Now you know. So this is my real part, 63 upon 13 square, and this negative negative 16 upon 13 square is my imaginary part. So now with this knowledge, we will calculate modulus of Z is equals to how much? So 63 complete square, or I think we are committing some mistake. Let's hope the answer comes 63 upon 13 square, that is real part, its square plus imaginary part. Imaginary part is minus 16 upon 13 square, its square, taking under. Done. So it will be how much? 63 square upon 13 raised to 4 plus 16 square upon 13 raised to 4, its under root. So 63 square, 16 square divided by 13 raised to 4, numerator under root upon denominator under root. Some mistake we did. Just 1 second. What is 63 square plus 16 square? Let me calculate. Are you getting, students? What is going on? Sixty-three square plus 16 square is 4225 under root, and the denominator is 13 square. Up till this point, is it clear? Afrin Puchita.
Yes, sir.
Now
Yes, sir.
4225 under root is 6 7, so this is 65. Yes, we are doing correct. This is 65 complete square, and denominator there was 13 square, so 13 into 13. So 113 gets cancelled, 13 5s are, 13 remains. Now this answer is same as the property that you could have applied, which so division. So modulus of numerator upon modulus of denominator, that is modulus of numerator is 5, modulus of denominator is 13. Work over.
Yes, sir. Sir, I used mod Z1 by Z2 formula, sir. So,
So mod Z1 by Z2 formula. So that there you use the property, that mod of
yes, sir.
Z1 by
Yes, sir.
Z2 is equals to modulus Z1 upon modulus Z2.
Yes, sir. Yes, sir. I did in that manner, sir.
So here I told you that you do not know that property as of now.
Okay, sir.
If x plus I times y is equal to a plus ib upon a minus ib, find the value of x square plus y square. Try it. If you are unable, ask me, then I will explain. Is it over, students? Students, is it completed? Please reply.
No, sir. Explain, sir.
Two methods. First is the traditional method that we did here. It's complete x plus iy. So first I will find x, then I will find y separately, and then I will take their squares and add. That is the traditional method that most of you do. X plus I times y is what's up? A plus ib divided by a minus ib. And this thing, if you want to calculate x and y, is actually what are you doing? We're trying to convert this division in the standard form. Real part plus I times real imaginary part. So we do it by, sir, a plus I, sorry, yes, a plus ib, a plus ib. So what it becomes? So the numerator becomes a plus ib complete square, and the denominator becomes, sir, a square addition b square. So now numerator, if I write directly, sir, p plus q complete square, the identity that we have for complex also, that is valid, we studied yesterday only. A plus ib complete square. Can I write it separately now, sir? It is a square minus b square. Actually it is ib complete square. So it is a square minus b square, and the imaginary part is I times twice ab. This divided by a square plus b square. This is my x plus iy. So what is my x plus iy actually? So my real part is a square minus b square upon a square plus b square. Addition I times twice ab upon a square plus b square. Clear up till this point? So what is my x, sir? The real part x. The real part x is here. And so what is my imaginary part y? My imaginary part y is over here. Got it? So you have calculated the values of, you have separately found the values of x and y. Whole complex number is in the standard form. So now what was asked? Evaluate x square plus y square. So x square plus y square will be what? X square plus y square. Means I am substituting this value. I have not taken the square of the left value. Okay. Don't think that I have taken the square of the left value. I have calculated x and y separately. This is just a comparison. So sir, my x is equals to a square minus b square upon a square plus b square, and my y is equal to twice ab upon b square plus b square. So what will be x square plus y square? So x square plus y square will be a square minus b square upon a square plus b square. Complete square addition twice ab upon a square plus b square complete square. So this will be equal to, so first is a raised to 4 plus b raised to 4 minus twice a square b square. This is the first numerator expansion. And the second numerator expansion is what? So 4 times a square b square. And the denominator in both the cases, the denominator is same. A square plus b square whole square. So do you realize that the numerator and denominator have become one and the same thing? A raised to 4 plus b raised to 4 plus twice a square b square divided by a square plus b square whole square. This is actually equal to 1 only because the numerator is what? Just the expansion. A square plus b square whole square.
Sir, one scroll down, sir.
So this 1 is my answer.
Sir, still you scroll down, sir. Done, sir. Next.
Print done, Dhananjay.
Done, sir.
Just 1 second, the digipad is hanging. Yes, now it's working. But there is a better way. This is the clerical work. The person who does not uses the properties properly, he does it by this method. And this method is given in your book. But we should, the properties that we have studied, we should be able to apply those properties. What is method 2? So this x plus iy, whatever that complex number is, this is my some complex number x plus iy equal to a plus ib upon a minus ib. You are telling x plus I times y is equals to a plus ib upon a minus ib. And whatever this complex number is by division, you are telling me to find x square plus y square. Means actually what you are asking me, sir, you are asking me somehow this x square plus y square is related to magnitude of x plus iy. Yes or no? Means actually it is not exactly equal to magnitude, it is magnitude square, but it is related to the magnitude. So what I will do, so if I do the magnitude sign over here, modulus of LHS is equals to modulus of RHS, nothing wrong in it. So modulus of LHS is what? Modulus of LHS is x square plus y square under root. Modulus of RHS is what? So modulus of the numerator upon modulus of the denominator. Modulus of the numerator separate and modulus of the denominator separate. Can I calculate the modulus of the numerator? Yes, sir, I can calculate. What it is? A square plus b square under root. So can I calculate the modulus of the denominator? Yes, a square plus minus of b whole square. So it is one and the same thing, a square plus b square under root. So x square plus y square under root is this value. This turns out to be equal to 1. But what has he asked? He has asked me x square plus y square. So the square both the sides and the answer is 1. Such small steps. That's it. Simple application of properties. Done?
Yes, sir. Done, sir.
Sir, could you please scroll down, sir? Yes, sir. 1 minute, sir.
Done. Okay.
Done, sir.
Sir, first answer is 4.
No, wrong. See here that 2 is equal to 2 plus I times 0. So modulus of 2 will be what? Don't think the modulus of 2 will be 4. Modulus of 2 is 2 only. So real part square plus imaginary part square, it's under root. Modulus of 2 is 2 only. I think you probably did that mistake. Modulus of 1 minus I
Yes, sir.
is what? Can I write directly modulus of 1 minus I is root 2? I think no doubt should be come over here. So modulus of first complex number, the first complex number is 2 upon 1 minus I. Its complete modulus. 2 upon 1 minus I, its complete modulus will be what? Modulus of numerator divided by modulus of denominator, which is equals to 2 upon root 2. So the final answer is root 2. Second, solution of the B part, what is the modulus?
Sir, one scroll up, sir.
Quickly, what is second modulus?
1.
Yes, correct. So magnitude of 1 minus I upon 1 plus I. Z1 divided by Z2 modulus. I can do the separation of the mod sign. Modulus of Z1 divided by modulus of Z2. This modulus of the numerator. Numerator, can I say 1 square plus 1 square under root. Don't make it I square. We are taking the imaginary part. X square plus Y square. Y is 1. Actually negative 1. But it is not I. I for India. It is not I. Okay. The imaginary part of denominator also, it is 1 square plus 1 square under root. So it is root 2. So the division is 1.
Sir, last answer is also 1.
Yes, last answer is also 1. Correct. Here also magnitude 3 plus 2i upon 3 minus 2i. The magnitude will be 1. Clear, Afrin Dhananjay?
Yes, sir.
Yes, sir.
Find the modulus of 1 plus I upon 1 minus I minus I upon 1 plus I. This is your NCRT question. How many of you think that the answer should be 0?
Yes, sir, I am thinking it's 0.
The answer is not 0.
So 1, sir.
what is the error that students commit? So see, this complete first complex number I will take
Sir, will
as,
it be 2, sir?
yes, it is 2. The complete first complex number is Z1. The complete second complex number is Z2. So what can I observe? I have observed that the error first I'm talking. So see what I have observed, that modulus Z1 modulus of Z1 is equals to 1. Modulus of Z2 is equals to 1. Correct? The previous calculations that we did. 3 plus 2i, 3 minus 2i, 1 minus I, 1 plus I. Okay. So Z1, Z2 both modulus are 1. So here directly the answer will be modulus of the complete complex number will be 1 minus 1 equal to 0. Answer is 0. What is the error in this calculation? The error in this calculation is, if you take the modulus of Z1 minus Z2, if you take something like this, the first fraction, that is first complex number Z1, the second fraction, second complex Z2, modulus of the difference, you are taking this to be equals to modulus first, modulus second, its difference. You are taking this equality, which is completely wrong. Got it? Like in simple real numbers also we used to do these things. In simple real numbers also, if I tell you real numbers how, let's say p minus q mod or p plus q mod is, whether it is equal to mod p plus mod q, no guarantee. Let's say take p is equals to 7 and q is equals to -3. So p plus q its modulus, what will be p plus q its modulus? 7 addition -3, that is 4 modulus, which is 4. But what is mod p plus mod q? Mod p plus mod q is 7 plus 3, which is 10. So they are unequal. Sometimes they are both equal also. The same property is here also. Okay, so Pujita, do you realize your mistake that this answer is not 0?
Yes, sir.
So how to do it? We have to just use the same formula. We will convert it into x plus iy using the trivial, the clerical method. So you have to actually find the real part and the imaginary part, and then squares and all those methods, square addition modulus. So z is equals to 1 plus I upon 1 minus I, subtraction 1 minus I upon 1 plus I. This is equal to 1 plus I whole square minus 1 minus I whole square divided by 1 minus I into 1 plus I. What is the first square? 1 plus I whole square. 1 square plus I square is -1 plus 2 times 1 into I minus 1 square plus I square. I will write here 1 square plus I square, that is -1 minus 2I. It's complete divided by 1 minus I into 1 plus I is 1 square plus 1 square. How 1 square? Actually it is the magnitude of the conjugate, z into z bar, so magnitude of z square. Okay. So 2i minus of minus 2i. So whether it is equals to 4i and denominator it is 2. So z is equals to 2i. Simply 2 times I. So what is the real part? Real part is 0 and imaginary part is 2. Representation on the Argan plane is something like this. This point. 0, comma. What is this distance from the origin? Distance from the origin is 2 units. 2r. Magnitude of z is equals to 2. Okay.
Yes, sir.
So today we'll stop over here. Probably on Monday that will be the last lecture of complex. Whole we will not take complex number in this whole 1.5 hours. We will not take complex on Monday.